Mass spectrometry. So this is another spectroscopic technique, but see here, I am using the term spectrometry instead of spectroscopy. Little change is there. We have seen in the definition that the spectroscopy is the study of interaction between the electromagnetic radiation and the matter or the molecule. But here in mass spectrometry, we are using a beam of electron. We are not using electromagnetic radiation. Because of that, instead of using spectroscopy, we use the term spectrometry. Okay. After that, we will see the basic principle behind this and what happened during the mass spectrometry that we are going to discuss in this video. You listen very carefully. So first of all, you try to understand this technique is used for measuring the molecular weight of the molecule, organic molecule, or we can find out molecular formula. So this is important to decide molecular weight of the organic molecule as well as its molecular formula. Now I am coming to the basic principle or what happened during the mass spectrometry that I am going to discuss. So M is a molecule, organic molecule. It is actually vaporized and then bombarded with a high energy electron beam. If you see here, whose energy is around 70 electron volt, that means 1600 kilocalorie. Generally, to break the sigma bond, we need 100 kilocalorie energy. That means 1600 kilocalorie energy or 70 electron volt energy. This much energy is sufficient to break all bonds in the molecule. So what happened here in the first step, when we irradiate this molecule, when we bombard this molecule with high energy electron beam, one electron is ejected from this molecule. It may be either from sigma bond or from pi bond or from n electrons, that means non-bonding electrons, and we get here radical cation. You can see here one electron is removed, that means a radical is formed, and loss of one electron, proton, the number of protons same. Because of this, one positive charge develop, and this is called radical cation. So first this radical cation is developed. Now see here, this radical cation is actually M plus and dot. This is called molecular ion because just one electron is ejected. That means if you see here, the mass of electron is negligible. That means whatever mass this radical cation is having is equal to its molecular weight. So the mass of this M plus dot is a molecular weight of the molecule. You can see here, it is the molecular weight of the molecule, and in this way we can find out the molecular weight of the molecule. So now this is also called molecular ion peak. This is also called molecular ion or parent ion. So peak will be discussed later. Now see what happened. Once this one electron is ejected and radical cation is formed from this molecule, it undergoes different fragmentation, and during that fragmentation different radicals are produced or cations are produced with different mass. So mass spectrometer actually analyzes the mass. This is again important word, important sentence. Mass spectrometer analyzes mass of cations only. It cannot find out the mass of radicals, which is neutral. Now see what happened. Once that cations and radicals or different fragments are formed after bombardment of high energy electron beam, cations are accelerated. We increase their speed in an electric field. Electric field is there in mass spectrometer, and then these cations are deflected in a curved path. This kind of path is there. This kind of curved path is there where magnetic field is applied. Yes and N. Magnetic field is applied. That means we are increasing the speed of cations, and then we are deflecting that cations by using a magnetic field. By using a magnetic field, what is the purpose? Purpose is to sort out these cations as per their molecular weight. So and they are determined, I mean the cations which are sorted are determined as per the M by Z ratio. M is nothing but the mass and Z is the ion charge present on that fragment. So this charge is 1. So if this Z is 1, actually they are sorted as per their weight, molecular weight, as per their molecular mass. So in this way, whatever cations are produced after the bombardment of high energy electrons, we get different cations of different mass. So we get different fragments of different mass, and they are sorted out, they are separated by using acceleration due to the electric field and by using this curved path where we apply the magnetic field. So all cations are now separated and they are going to the detector one by one. So now see here what happened. The mass spectrum is plotted. How that mass spectrum is obtained, that I am going to discuss now. On one axis, relative abundance is taken. Relative abundance means the quantity of that particular cation in percentage, and on another axis M by Z ratio. Actually the mass, Z is always 1, but we call it as M by Z ratio. And this is a typical picture, I mean this is the typical spectrum, mass spectrum, where we get different lines. So high intensity line, you can see here high intensity line whose intensity is considered as 100% abundance, 100% intensity. So this is the tallest peak, and this tallest peak is called now a base peak. So one peak is a molecular ion peak, which is at highest M by Z ratio for that particular spectrum. So the molecular ion peak is at highest M by Z ratio, which is equal to the molecular weight of that particular compound, organic compound, and the tallest peak present in the mass spectrum is called the base peak. Sometimes molecular ion peak is also a base peak. Now to illustrate this, to explain, you can see here one example to understand this basic theory behind the mass spectrometry. So I have taken here very simple molecule, methane. It is bombarded with high energy electrons. So one electron is ejected and we get here radical cation. If you count the mass of this, so we get M by Z ratio is, Z is 1, so mass is what, 16, 12 carbon and 4 of hydrogen, so it is 16. So we get one peak at M by Z 16. So another fragment is what, one hydrogen is departed as a radical, so this is not detected. So 3 hydrogen left. Now one hydrogen is departed with 1 electron, so this cation is formed. So its mass is 15 because 1 H is removed. So mass is 15, Z is 1. So another 1 electron is rejected. We get a M by Z ratio 14, 1 electron, and as per if you continue this ejection of electron, we get M by Z 13 and M by Z 12. So we must get how many? 1, 2, 3, 4 and 5 peaks. So that peaks I have shown here. So you can see here M by Z ratio 10 to 20 and the all peaks are, you can observe here in between 12 to 16, and this highest intensity peak is called the base peak. And in this case, this is also a molecular ion peak, because you can see the highest M by Z ratio is only for this peak. So this is molecular ion peak as well as base peak, and remaining all peaks are for different fragments. So we can work out this on paper for different molecules. If the molecule is bulky, so that is again we have to plan different fragments on paper, and we can match our fragments with actual mass spectrum of that particular molecule. So this is all about mass spectrometry. Thank you.